Welcome to 7.4, chapter 7.4 for the summer. This is dealing with equations and inequalities. So what we see here is we have an equation. We're missing a variable here. And what we want to do is we want to solve and isolate it. There's a number of ways to do this. I'll show you two ways. One of the quickest ways is to get rid of all these fractions. You look at your denominators, and if somebody who doesn't want to deal with converting them and getting them with common denominators, we can get rid of it by multiplying by the common multiple. So common multiple of 5, greatest common multiple would be 25. So if we multiply everything by 25, and actually this is in the numerator, these are in the denominator, so when you multiply this times this numerator cancels with this denominator, leaving us with the numerator. When we multiply this times this, the numerator cancels with the denominator. We're left with 5 in the numerator with the negative 4, which makes negative 20. And then we multiply this times this, numerator, denominator, cancels 5, and you're left with negative 20. Now this equation looks way easier than this. And all we did was really simple. We just multiplied everything by 25. This is a proportional equation. These are equivalent. This big ugly thing is equivalent to this because they were proportionally. We just multiplied everything by 25. Now we can solve for the variable by doing the inverse operation of subtracting 20. The inverse of subtracting 20 is adding 20. These cancel. You're left with x equals 0. So to me, that's going to be your easiest way to do this problem. I would advise getting rid of the denominators. Another way to do this problem is, we don't want to clear, we want to clone the page. Now we want to clear the ink. So one of the other ways we could do is, let's get rid of this. This is ugly and in the way and not necessary. All right, so if we want to isolate the variable, this variable is being divided by 25. It's also being subtracted by 4/5. So which one do we get rid of? We get rid of adding and subtracting. The inverse of subtracting 4/5 is adding 4/5. So we could add 4/5 to both sides of the equation, leaving us with x divided by 25 equals 0. The inverse of dividing by 25 is multiplying by 25. These cancel, denominator, numerator, leaving us with x equals 0. 0 times 25 is 0. So both steps are efficient. Both steps are really good. If you're comfortable with fractions, you can leave the fractions in there. If you're not comfortable with fractions, well, this technique gets rid of those fractions. So either way, I don't care which way, both ways will be used in high school. Number 2, a number a plus 7.1 is less than 5. Write a word sentence and as an inequality. So write this word sentence as an inequality. We don't have to solve it. A plus 7.1 is less than 5. That looks like that. We don't have to solve it. All we have to do is convert it. Is less than is the important thing that you have to pay attention to. So inequalities, and also it tells you it's an inequality. Inequalities are things like less than or equal to, greater than or equal to. So those phrases are important to understand. Now we want to graph this solution. So first of all, we have to solve. We have to isolate this inequality. And what's happening to my variable? 7 is being subtracted. The inverse of subtracting 7 is adding 7. We balance the equation. X is greater than or equal to 9. So we have to understand greater than or equal to and less than or equal to are going to have closed circles because we want to include the solution, the boundary. If we have greater than or less than, it's going to be an open circle. That is not including. So we do not include the boundary. So the boundary is 9. We want values that are greater than or equal to 9. Now, we want our variable to come first. When we read this, we tend to want to be able to read it as my solutions. The solutions are greater than or equal to 9. So I find my 9, this is where 9 is, and I'm going to include my boundary. So I'm going to have a closed circle, and it's going to be greater than, and we're going to push it to the right. So we're going to do it there. I do not want this. Well, let's do this first. Can I do that? Nope, I can't. I don't want this stuff. Let's do this. Let's do that. No, can't get it. Nope, come on. Grab it. Grab it. Thank you. Nah. Sorry. Nope, don't do it that way. Grab it. Grab it. There you go. Now we're going to group it. Nice. Thank you. Sorry about that. I don't want this on the number line because it's hard for me to determine to see whether it's open or closed. This graph should always be above. There's no line dragging down. It looks like this. It's a closed circle, and then you show me the direction, okay? Very much like these, open circle, closed circle going left, right. These are segments, etc. All right, graph the solution. Whoop. Graph the solution. We have 5x is less than or equal to 45. What's happening to my variable? It's being multiplied by 5. The inverse of multiplying by 5 is dividing by 5. X is less than or equal to 9. Less than or equal to, again, we're here. Closed circle because it's equal to. Less than is going to go to the left. And I can see my graph. Everybody is very clear on which direction it's going to. Okay, now we got a two-step equation. So negative 6b minus 6 is greater than negative 36. We're going to add 6. We get rid of things being added and subtracted first. Negative 6b is greater than negative 30. Negative 6 is multiplying. The inverse would be dividing by negative 6. At this point, we have to remember one of the rules that's very important for us to remember is that when we divide both sides of an inequality by a negative, we have to flip the inequality sign. So that now becomes less than, and that's 5. So my solution is b is less than 5. We find 5. It is open circle because it's not including, and then we graph to the left. When we divide both sides, we're moving the variable across. I'll go into that during the school year, but you should know mathematically why we're flipping the inequality when we divide both sides by a negative. I won't go into detail on this video, but we will talk about it during school. Now we're back to equations. We have the equation d plus 2/5 equals 9. D is being, what's happening to the variable, 2/5 is adding it. The inverse is subtracting 2/5. So we get D equals, we're going to turn 9 into fifths. There are 45 fifths in 9, and minus 2/5 gives us 43 fifths. So D equals 43 fifths. That should be pretty good. Solve this. Ooh, this is good. Not really, but that's okay. H. So H is being divided by 5. The inverse of dividing by 5 is multiplying by 5. You get 70 equals H. That's good. We don't have to graph it. Hold on. Just staying with it and making sure that everything is okay. Here we go. Oh, here we go. This is the better one. I like this problem. All right, what's happening to to the variable is being multiplied by negative 2/3. The inverse would be dividing by negative 2/3. I don't know too many students who want to deal with that fraction inside of a fraction. That's not fun. You could do it, but it's just not really conducive and fun. So multiplication has two inverses. Very important for you to recognize that. Multiplication has two inverses. It's the only operation that has two inverses. The most logical one is division, right? The inverse of multiplication is division. Everybody knows that. But the other one is multiplying by the reciprocal. That is also the inverse of multiplication. Reciprocal. I don't know how to spell reciprocal. So the reciprocal of negative 2/3 is negative 3/2. Negative 3/2. These cancel. Any number multiplied by its reciprocal leaves us with the variable by itself. Now I'm not going to write negative 60/2. Remember, I'm going to cross cancel. That is going to be way more efficient. We don't want to make things bigger just to make it smaller. So number 8 is going to be p equals negative 30. Tell whether negative 2 is a solution. Well, if it's a solution, when we plug it in and simplify, it needs to be a true statement. Solutions are true. So is 6 less than 7? Yes, that's true. So that means 2 is, so 2 is a solution. So my answer is yes, it is a solution. The solution isn't 6, the solution isn't 7. The solution to this inequality, one of them, is negative 2. So negative 2 is a solution. Sorry. Area of a triangle is no more than 32 square inches. Select an inequality. So it says the area is no more than. So it has to be less than or equal to 32. Some students would say, oh, can it be equal to it? Does it not? Can it not be equal to it? So it says no more than. So it can equal 32. It just can't be more than 32. So my area must be less than or equal to 32. Now the formula for a triangle is the area is 1/2 base times height. And we have my base is 8 inches. And I don't know what my height is. My height is A, is less than or equal to 32. We can simplify this. This makes 4A is less than or equal to 32. What's happening to my variable? It's being multiplied by 4. The inverse is dividing by 4. So my A, now that's bad that they use A for height because we have big A for area. That's kind of silly. So my height must be less than or equal to 8. So select any inequality that represents A. All right, so there's a couple situations here. So it is not A is less than 32. That's a no. 1/2 8 times A is less than 32. That's close, but it can be equal to, so that's no. 1/2 8A is greater than 32. No, that's a no. 1/2 8A is less than or equal to 32. We found our solution. Yes, that is our answer. So select the inequality. It would be that one. Solve for Z. Let's put that there. Let's just, sorry, I'm multitasking while I do this. Solve this one. Okay. So let's take this and we'll write it up here. 4Z minus 4 minus 2Z is greater than 8 minus 6. So we always want to simplify first before moving. Simplify first. Always simplify both sides before you can do it. We've got like terms here. 4Z and negative 2Z makes 2Z minus 4 is greater than 8 minus 6 is 2. And now we have a two-step. We're going to get rid of the addition and subtraction first. 2z is greater than 6. We're going to divide by 2. And z must be greater than 3. So greater than 3 is going to be an open circle over 3. And my solutions are going to be greater than 3. Things greater than are to the right on the number line. And that would be our answer. Oh, there were two parts to that. Didn't see two parts to this. Second part was way down here, the solution. So the solution is my height. My height, not my area, because it's A. My height must be less than or equal to 8. Sorry about that. Just multitasking here. Here is Z is greater than 3. We're graphing it. That looks good. I don't think there's any secondary. That's good. Okay. Number 12. You have $54.75. You earn additional money by mowing lawns. Then you purchase a new pair of shoes for $79.99 and have $34.76 left. How much money do you earn mowing lawns? So I have $54.75. I earned some money for mowing lawns. We'll call that M for mowing. Then I purchase a new pair of shoes. Baby needs a new pair of shoes. So I'm going to subtract $79.99, and I have $34.76 left. So that's the equation. I start with this. I add my lawn mowing money. I subtract for the shoes, and it should equal $34.76. So I'm going to combine like terms first. I know I need to isolate the variable, but I'm not going to move them separately. I'm going to actually subtract those. I'm going to simplify. We always want to simplify. And that's $54.75. So we're subtracting. That's a 4. That's a 2. That's a 5. And that's a 2. So we get M minus 25.24. We had more negatives than positives. Equals $34.76. What's happening to my variable? It's being subtracted, so the inverse is adding 25.24, and my mowing money is going to be 0 carry 0 carry 0 carry $60. I made $60 mowing lawns. Should be your answer. So now we look at the question. How much money did you earn mowing lawns? I earned $60 mowing lawns. That's not bad. How many kids mow lawns in Manhattan Beach? Probably not many. A cyclist travels north along a road at a constant speed of 28 miles per hour. At 1 p.m., a runner is 68 miles away, running south along the same road at a constant speed. They pass each other at 3 p.m. What is the speed of the runner? Okay, this is good. So there's lots of variables going on, lots of things going on. So I like drawing it. I like making a diagram. A cyclist is traveling north. So we've got this cyclist, and he's traveling north at a rate of speed and etc. At 1 p.m. Starts at 1 p.m. A runner is 68 miles away. So my runner is going south along the same road at a constant speed. They pass each other at 3. What is the speed of the runner? Cyclist traveling north at a constant speed of, so his distance and rate, the runner is 68 miles away. Okay, so this cyclist is running at, we have this formula, distance equals rate times time. Distance equals rate of speed times time. So we know the rate of speed for this cyclist is 28 miles per hour times the time. That's going to be his distance. That's the distance for the cyclist. At 1 p.m., the runner is 68 miles away. So this distance to the cyclist is going to be 68 miles away from the cyclist at 1, running south along the same road at a constant speed. Okay, we don't know what his speed is, so his distance is going to be, we'll call it R for rate times time. So distance equals rate times time. They pass each other at 3 p.m. Okay, so that's 2 hours. So we know what time is for both of these runners. So his new formula is D equals R times 2. His new formula is D equals 28 times 2. And if we add these two distances, it should equal 68. So distance of the runner plus the distance of the cyclist should equal the total distance. We'll say distance total. So his distance is 2R. The runner is 2R. His distance is 28 times 2, which is 56, should equal 68. That's the total distance. So now let's solve it. Minus 56. 2R equals 12. Divide by 2. R equals 6. So the rate of speed for the runner should be 6 miles per hour. 6 miles per hour. That's pretty fast for a runner, personally. Yeah, so that's how you do it. That's a good one. That one takes a lot of practice. Mr. Mac can do that because he's done a number of these. If you want to get good at word problems, if you want to be able to comprehend word comprehension, and you want to be able to comprehend and know how to break things down, you need to practice them. This doesn't happen because I'm just, and notice the organization. It's not just a bunch of jumble on my paper. I'm writing things, I'm moving things, I'm writing different equations, I'm putting information down, but it's very organized. So take note why things are successful. Number 14, a store manager predicts that 80 hats will be sold if each hat costs $15. A store manager predicts that 80 hats will be sold if each hat costs $15. Okay. The manager predicts that 3 less hats will be sold for every $1 increase in the price. For what price can the manager predict at least 50 hats will be sold? Okay, well, so at 80 hats, so we'll put hats and we'll put cost. When we're selling 80 hats, it's going to be $15, and they're saying 3 less hats will be sold for every $1 increase. So if we increase it by $1, so cost gets increased from 15 to 16, we're going to sell 3 less hats. So that would be 77. And so $17 would take us to 74. $18 would take us to 71. And now we want to know, these are the number of hats. This is the cost. These are dollars. So 19 is going to be 68. So once we see this pattern, now we might be able to say, okay, when does the hats equal? And it's going to be, I think it's going to be 80 times the quantity. No, that's not what it is. I mean, I could keep going, but I kind of want to make an equation. I'm trying to think what's happening here. So we see that as hats increase. Hi, you want to be in my video that I'm making right now?
Sure.
Oh, lovely. You're in the video.
Nice.
What can I help you with?
Do you need sizing sweatshirts?
I do not.
Okay.
I appreciate it. Thank you for looking out for me. I will see you on Wednesday. Are we meeting Wednesday?
I think we are.
Okay. Love it. Can't wait. Yep. That's a 7th grader. So we look, as we increase 1 in C, we're going to decrease 3 in h. So how can we write an equation? If we go backwards, so we want to know hats. So 8, now let's do, well, that's the slope. And if we did xy, I'm just trying to liken it to an equation and writing a slope. So 1/3, negative 1/3. So C equals, I think I got it, negative 1/3 h. And backwards would give us, that's 45, so 125 plus 125. And what we can do is we can write an equation, then we can plug in this stuff. So if C equals 15 and H equals 80 plus 125, does it work out? So 15, 3 go, that's ugly. That's not going to work. 3 doesn't go into 80. Should I have just continued on with this? See, I like 0. If I go backwards this way, 0 gets me to, should it be, maybe that should be H and C. Let's try that. Let's switch those. And look, you see that Mr. Mac's not 100% confident in this technique. I'm trying it, and yeah, it takes some time. You wouldn't use this technique if you were in a timed situation. So if I flip those and make that 15 and make this 80, does it now work? But I kind of just want to do it. I'm practicing something. I have one technique that I could have continued. It would have taken me a little bit of time to get to 50. And I would have been 100% certain, but now I'm just trying because, hey, this is good practice. This is something that I should know how to do. This will give us negative 5. Well, that doesn't equal 80, does it? No. So that clearly is not the right technique. So I definitely messed up somewhere. Not sure how I didn't end up. That actually probably should have C times, maybe it was times 3, not, yeah, whoops. That's what it should have been. This should have been times 3. I think if it's times 3, negative 3, I think it works. Minus 3, that gives me negative 45. Nope, that's not going to give me. That doesn't get, that's 25. Hello. Negative 1, or that's 125. Does that give me, that gives me 80. Yes, 80 equals 80. Now, that's not negative 1/3. That should just be negative 3. Some reason, my slope was reversed. Rise over run should be, but maybe because I did my variables wrong. All right, so I know that this equation now works because I tested it. And now I want to know, when will I get 50 hats? So hats equals 50. What is my cost going to be? So I can write this equation. And what is the, for what price? So I'm going to minus 125 minus 125 gives me negative 75 equals negative 3C. We're going to divide by negative 3, divide by negative 3, and we get 25 equals C, yeah? Yeah. So my cost will be $25. Let's keep going and see when we get to 50 hat. My cost will be $25 per hat. So we'll go 65 is 20, 62 is 21, 59 is 22, 56 is 23, 53 is 24 and 50 is 25. Mr. Mack, why didn't you just do that? I could have, but just want to challenge myself. So I see that this is going to be my answer, and then I also see how I could create an equation to help me with that same thing. A little bit longer, but we're in no rush. We're learning this summer. We're trying challenging things, and we're going to try fun stuff. So maybe if I flip these and move the cost over here and the hat here, it would have actually made a better equation. So you could do an equation. So if we do that, that gives, no, we're done. That's a good one. We got it. Oh, and so what was here it is. For what price does the manager predict 50 hats? So my price must be less than or equal to $25. That would be the answer. P must be less than or equal to 25. Manager predicts sold if hats. Manager predicts 3 sold. Every increased price for what price does the manager predict? At least. That's why. At least. So that's why we use the inequality. Alrighty. You attempt an obstacle course 5 times. The table shows the amount of time it takes for you to complete the course on your first 4 attempts. For what values of X will you have a mean, an average? This means average of no greater than. So you have your 5 attempts. So you have attempt 1, you have attempt 1, attempt 2, attempt 3, attempt 4, and attempt 5. And we're going to average those, and it must be no greater than 150 seconds. So that average must be less than 150 seconds. So we know how much the first time is, 136. We know how much time it took for your second run. We know how much it took for your third run. We know how much it took for your 4th run. And then we don't know the 5th run. That's what we're solving for. And we could write this equation. So this is an average, right? Number of times divided by the number of events. The sum of the times divided by the number of events. So first thing we can do is we can get rid of that division by 5. Because I can't get to my variable because it's being added and divided. So we're going to get rid of that division first. And then that gives us 136 plus 127 plus 154 plus 166 plus my missing time must be less than or equal to 750 seconds. Now we could subtract each one, but remember we like to simplify. So if we add those 4 values up, we got 136, 127, 154, 166, that's 10, that's 12, so that's 22, that's 5, that's 10, that's 18, that's 1, 2, 3, 4, 5, 582, so X plus 582 must be less than or equal to 750. Minus the 582, and we get X must be less than or equal to 750 minus 582, gotta borrow, 8, gotta borrow, 6, 1, so 168. My time must be less than or equal to 168. So, what? Now that's no greater than what did I do a mistake? Did I make a mistake? Let's see about my adding. That's 13. Hello. Not 12, that's 13. 23, excuse me. That's 13 plus 10 is 23. Sorry, maybe you saw that. Again, Mr. Mack's gonna make mistakes. He is not perfect. He's doing math. Some of the math he's doing in his head, which doesn't bode well. If we can use a calculator, we'll use a calculator. Otherwise, we're writing it down. I write down a lot of work. So X must be, oh, and here's the other thing, is I made a mistake and my answer wasn't there. So I didn't just guess. I went back and found my mistake, and now I'm 100% certain on my solution. I know my solution is going to be this one. So that's the reality is if you make mistakes, don't just blow through the door and just guess. If you make a mistake and your answer is not one of the choices, go back and check your work. Okay, so that's the important thing. And these must be threes. So it's okay. You're going to make mistakes. I'm going to make mistakes. Now, the difference is I expect us to find those mistakes when we make them. So keep working. Always check. Oh, here we go. There's your answers. So check your work. Always check your work. Try to find mistakes. That's our goal, is trying to find when we make the mistakes that we can catch them and correct them and improve our score. So every mistake that you catch and you fix is an improvement in your overall score. That's the benefits. That's the beauty of it all. All right. Good luck.